Not really much to talk about on this Predicta. This is the PC board. You can see I did some cap replacement. These yellow caps over here. Still had a couple more to go. That one went. That white Elmenco went. I think I left this cap alone. This vertically mounted cap. I clipped the lead, tested it. It tested fine. No leakage. Correct value. So I didn't have to do anything with that. I think there might have been a couple of others here. Maybe I got replaced. I can't remember where I was at this stage. There was a couple bad resistors in here causing some issues with some sync early on. The damper tube had a filament that was coming and going, and it had to do with one of the ground stakes. It wasn't soldered properly. Predictas have all these ground stakes all over the boards that hold it down to the chassis, and they're problematic. These are these little integrated circuits that are resistor capacitor circuits that are all encapsulated. A lot of people like to replace them, in the idea being that they're problems and they're a pain, but in my case they were fine. I didn't do anything with it. I don't like to replace things unless there's an actual problem. Although I understand the reason why these are a pain to work on and people don't want to dig into them too much. So there's trade-offs there. This capacitor, this can cap, is the original filter can. I didn't do anything with it. It checked out fine. It works fine. The same could be said, it doesn't show it on this picture, but there's a doubler capacitor just over here. Again, it tested fine. There was one high value, low voltage skinny cap that was, I think, part of the it was a cathode bypass. I don't know if it's for audio tube or for the vertical, but anyway, it was the only cap that was open. I restuffed it. This tube, which was the vertical kept winking out on me. It collapsed down to a line. It turned out this tube had a problem. These tubes have kind of an unusual design. They have a pin that goes down to the PC board. Then a piece of metal comes up, over, and down and to form a socket. And that over part, which is a bridge between the pin that goes into the PC board and the part that's formed into the socket, that bridge it connects us to, can fracture. And it's not a real obvious fracture, and it's weird because you can't really see it. And if you're checking voltages, you'll stick the test probe down and you'll either touch the pin part, which reads voltage of course, or you'll touch the tube part, and when you push down, the pressure from the meter leads will cause the brake to seal up, and then you get a regular voltage. The only way to really test this and know for sure you have a problem with the tube socket breaking is to use a tube extender, which goes in like a tube and then has leads that you can touch, and that way it sort of simulates the tube itself installed in the socket, and if you have a problem socket, it'll show up real quick. Anyway, this socket had to be replaced that holds this vertical out tube, which was easy because it just so happened that underneath this PC board is a fully enclosed metal chassis that this thing's soldered to, but there happens to be a large opening underneath this tube that let me desolder it and replace with a good tube socket. If you're replacing these kind of tube sockets, the best way to do it is to bust the tube socket up on the top, which usually isn't a problem. The problem is keeping it together more than anything else. But anyway, all the plastic gets chunked up. Take the tube out, the plastic's all chunked up. Chunk it up if you need to with some diagonal cutter or something like that. Careful not to put any stress directly into the board if you're breaking it up. And then you pop out one pin at a time. You just heat the socket from the bottom, push up, and the little pin will just pop out. You clean it up, get some solder wick, get it all nice and clean, make sure it's all free, install the new tube socket, snap it down into the holes. What you don't want to do is have those holes filled with solder, and then you press down, you end up pulling some of the metal, the copper cladding off the PC board. So that's why you have to make sure those holes are clean and everything just snaps into place real well. The tube sockets are literally designed to sort of snap in place and hold in. This tube socket, which is for a audio out, it's a 6BQ5, is a little bit flaky, but not so much that I had to replace the socket, especially since it was sealed on the bottom from the metal shield. I didn't really want to do it. I was lucky. It works okay. Um, I mean, again, the correct way to do it would be to remove the metal chassis by unsoldering all these solder points and unconnecting all these wires that are wire wrapped, all these terminals. It's a real major pain. I didn't want to do that. I was able to replace all these caps, all but I think one, from gaining access to the PC board from the bottom through the various holes. Like there's a big hole here, there's a partial hole here, there's a hole around here. And if you're careful, you can take a soldering gun, not an iron, but a gun, and you can put a bend into the actual tip and kind of work your way up in, press the tip up against the solder with the solder wick, pull the trigger, takes off the solder, and then you can get the part out. And as far as soldering it back, you just take the tip, go back up in there, and very strategically get your solder in place. And it's a little bit of work, but you can replace probably 90% of the capacitors on this PC board without removing the PC board from the chassis. Again, which is a major pain. And it's the way I would do it, unless I knew I had problems that required me. Like, for instance, if I had to replace this tube socket, there's no way you can do it without pulling the chassis. That's just the way it is. Anyway, that's the board. I think the other problem I had with this one was this was one of these linearity or height pots. I can't remember which one it was. It was really flaky. I had to replace that. But other than that, it's good. Like I said, it still has the original CAN capacitors. It runs fine. I'll leave it on for an hour. No problem at all. So, contrary to popular belief, these cans can be fine. They don't have to be replaced. If you want to do it because you're concerned about it being reliable, I understand that. It's my TV. It's not for a customer. So I'll just deal with it. I did add a fuse to the B plus, which you can't see in here. So if this cap ever did short out, the fuse would pop, and that would take care of that anyway. So I'm not overly worried about it. I think I actually have a fuse with a thermistor, if I remember how I set this up right. The thermistor acts as a surge limiter. Because it has a solid state rectifier instead of a tube type. It has immediate B plus, and this cap looks like a pretty big load when it first turns on. So anyway, the thermistor brings the B plus up slowly, keeps the current limited, so that the fuse can be rated very conservatively to blow if the B plus current just exceeds factory spec by just a little bit. Anyway, that's it for the Predicta. I hope you enjoyed it. Thank you. Bye.